Assalamu alaikum wa rahmatullahi wa barakatuh. Teddy, thank you very much for inviting and for giving me the honor to present the work to the audience, the Malaysian audience. I had the pleasure of visiting Malaysia a couple of years back. I enjoyed it, and this is now an online experience that I'm going to be sharing some of my opinions with you regarding to 5G and beyond. Let me share my screen. I hope you can all see my screen. Like Teddy said, I am a professor in two different universities, one in Turkey and one in the US, University of South Florida. I'm doing research nowadays beyond 5G and 6G, but I have been doing research over the last 10 years on 5G related areas. If you ask somebody to make a presentation on 5G independently, probably there will be 50%, even more than 50% overlap. So Dr. Tariq covered, that 50% that I was also planning to cover. So I'm going to skip through those very quickly. I don't think I can do a better job than what Dr. Tariq did, especially in the applications of 5G. He did an excellent job in covering those areas. So I have some of those, but I'm going to skip them very quickly. He also mentioned about the evolution of wireless. I have a slide. Actually, this is something that it's almost a must to cover in any presentation. I'm gonna also very quickly skip through this, but I'll talk about some more technical aspects of this evolution. We are now on 5G, but the whole era of cellular communication, where the wireless communication hit the market. Communication has been there even long before, but mostly used for military, for public safety, and those kind of applications. But when the regular people started using these cell phones, it goes all the way back 1980s when the cellular concept has been introduced in early 1980s, which we call it the first generation cellular systems. Started with analog. The focus was voice, where people can communicate. Data there at that time was not the main thing. The voice was the main thing, and the focus in terms of the design criteria to provide service to as many users, as many people as possible for a given spectrum. So that's what we call capacity. And we achieved this by reusing the frequencies, because the frequencies are very limited. At that time, even it was further limited. Nowadays, we are opening new and new spectrum bands, but at that time, we had a smaller spectrum availability for the operators. So we had to reuse them to increase the capacity. So reuse was basically the main focus of the cellular technology. And later we learned how to communicate utilizing digital techniques with the second generation. And the most famous one, as you all know, is GSM. But at that time, there were different versions. In America, we were using IS-136, American Digital System. In Japan, we were using Pacific Digital Cellular, PDC. In Europe, GSM was popular, but later the success of GSM spread throughout the world, and GSM became one of the most successful cellular technology. Even today, we are using it, as Dr. Tariq mentioned. And there is a sunset coming up, but even in Turkey, we were planning to have a sunset in a few years, but we have still so many users utilizing these second generation systems. Probably we're going to extend it a little bit more. Later in 3G and 4G, we started putting data into the picture. I was working at Ericsson at that time when we developed 3G, but the applications, even though 3G was designed technically very sound, but the operators were not willing to deploy the 3G technology because the mobile phones were not ready at that time, because the screen size is very, very, very small, and having a high-speed data is a luxury at that time for many people with that kind of devices. And we waited so long until these smartphones started with iPhone, the first version of iPhone, then later many other smartphones. When they hit the market, then the 3G became real, and operators started to deploying it. And then all of a sudden, that rates were not sufficient enough, because these devices became so popular. People started browsing the internet, and then doing video communication, voice over IPs, internet browsing, and all kind of applications overwhelmed the networks, and the data rates were not sufficient. The 3G data rates were not sufficient compared to the wireline, the one that we are used to. Then the 4G hit the market with true mobile broadband, higher speed data. Again, up until this point, the focus was earlier voice, later voice plus data. Earlier, as many users as possible. Later, the users plus the speed were the main criteria, main reasons how we optimize the networks, how we optimize the design. And in terms of the network, we have base stations communicating with the users. Users are usually communicating with a single base station. If they are moving from one area to another area, they do handoff, switching the communication from one base station to another one. And we call it a single layer, one cell connection, single connection point. And networks cells are more like a homogeneous networks. Mobility is very important. Coverage is very important, and people are communicating. So that's where we were lately. Okay, then came 5G, and 5G, even though Dr. Tariq beautifully explained, can be explained as a revolution or evolution, depending on how you interpret it. From this perspective, it is more like a revolution, because 5G changed the landscape of wireless communication. It wasn't about users anymore. It isn't about voice anymore. It isn't about data anymore. 5G intended to penetrate to everything in our life, not to the people, but to the objects, to the devices, to the things, to our heart, to our brain, to our plants, to our refrigerator, to our grid electricity, to our water system. So everything. So what Dr. Tariq mentioned, this is a verticals. So many applications. So with the 5G, even the automotive companies became a communication company. With the 5G, the companies like Facebook, companies like Amazon, companies like that you cannot even imagine, became a communication company, because communication has become the most critical aspects of their business. So therefore, 5G is gonna touch upon everything in our life. From this perspective, we can call this as a revolution, because of this wide variety of applications, diverse application classes, beyond voice, beyond data. Sometimes we can explain this of connecting everything, Internet of Things, okay? And then, and creating a cyber world where the human is at the center of it, but everything is around it is communicating. Okay, so from this perspective, when we look at the requirements, it is not just capacity anymore. It is not speed anymore. We have also wide variety of requirements and metrics, like Dr. Tariq mentioned. Latency is one of them, very critical, because with the 5G we are integrating into self-driving cars, so that cars can communicate with each other. We are integrating into our health sector, where doctors can remotely do the surgeries. So there are applications where the latency is extremely important. But there are also applications where power is extremely important. There are applications where cost is very important. There are applications where many other things, which we call them metrics, okay, the requirements of that specific application, diverse set of applications and diverse set of requirements. So with 5G, we intend to make one device, one network, one technology that can do everything. Okay, so in the old days, we had different standards, different technologies to address different requirements, like Wi-Fi for more like a in-office, in-home type of applications, Zigbee for more like IoT applications, Bluetooth for a different applications, LoRa for low power wide area network. So we designed a different technology for a different application with a different requirement. With 5G, we said that we want to do one thing, one technology that can do all. This is a very aggressive goal, very aggressive, standard, basically. Therefore, from this perspective, it is unique and it is very revolutionary. So what is ahead now? Now that we understood 5G, what is ahead? Well, ahead of the things is 6G. There are so many publications over the last years, more than 200, that's describing 6G. So how do we define 6G? There isn't really a clear definition. Everybody has their own versions. But from my perspective, 6G is more like a flexibility. Okay, it's a 5G started within the physical layer, within the other layers, to make a technology that's robust and flexible enough so that it can provide service to these diverse applications. But we weren't ready for that kind of flexibility when we designed the 5G. So I'm not sure whether 5G vision, okay, it's more like a vision, it's more like a dream, that 5G dream will be able to achieve all these goals that we had in our mind. So probably, along this, goal and vision, over the next 10 years, we are going to develop, physical layer structures, modulation techniques, waveforms, multiple accessing techniques, scheduling techniques, all kind of things that's needed, flexible enough, robust enough, so that this dream can be achieved. That's maybe the fixed 6G, together with the artificial intelligence, machine learning, together with some more learning and sensing capabilities. So that's what I think 6G is gonna be. Again, nothing is defined yet. Everybody has their own flavor, but this is my version of 6G. So what have we learned over the last 30, 40 years? We started with smaller bandwidth, because voice doesn't require that much bandwidth. 20 kilohertz, 30 kilohertz were more than enough. We started with that. Now the bandwidth became larger and larger and larger. Nowadays, we are talking about 400 megahertz of bandwidth in 5G. But we came from 30 kilohertz to 400 megahertz in stages. Every standard has come up with a technique that requires more and more bandwidth because of data, because of all these new applications. Not just becoming bigger in terms of the band that we are using, it also became more flexible, the way that we are using the bandwidth. Earlier in the earlier standard, it was fixed. Later, we were able to combine different bands with carrier aggregation. Later, we learned how to use the bands flexibly, dynamic spectrum access, even in 5G, one of the main critical things. And then we also learn how to use part of the band, fractional bandwidth utilization. For some applications, you don't need the whole band, especially for IoT applications. So we want to design a system. If not necessary, you can use a smaller portion of the band. If your application needs a wider band, you can use, so you kind of like expanding the utilization of the band. Even the base station can support all these applications. Depending on the user device, you can adapt, you can change. So that was very important. And also in terms of spectrum, we started with less than 1 gigahertz spectrum carriers frequencies, later 1.8, later 2.4, 2.5, and then 3.5, and then we are now going up, 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 up. Nowadays, we are talking about millimeter wave frequencies. We learn how to use higher and higher frequencies because there isn't really much room in the low spectrum band. And in 6G, now we are talking about terahertz type of communication. We are learning how to utilize those frequencies along visible light communication. In terms of utilizing the spectrum efficiently, every standard come up with a set of techniques that can increase the spectral efficiency. How many bits that we can transmit over a given spectrum. That's very critical. Utilizing techniques like better modulation techniques, better waveform techniques, utilizing multiple antennas and making the cells smaller, large cells, small cells, picocells, microcells, picocells, femtocells, and also coming up with heterogeneous networks, cell within a cell, and then coordination of all these cells became so critical to utilize these frequencies as often as possible. Okay, so for spectral efficiency, how many bits that we can transmit for every hertz per second and per meter square. So we want to do more and more of these transmissions, plus adaptation and cognition capabilities. So this is a very interesting slide that describes what we have seen so far. Before 5G, it is very rigid, not flexible standard. I sometimes call it standard for dummies. So everything is well defined. All what you have to do is to connect the dots to get the picture. 5G it's the things that you can do. 5G is infinitely many. Okay, so flexible, so many applications that you can support, and so many different pictures that you can create from these dots. So along with these, flexibility in the network level, also in the radio access technologies level, Open RAN and also network slicing became so critical with 5G and beyond. Okay, so that we can create multiple slices, multiple application classes by connecting these dots in a flexible way, with different way. We can have different applications, we can support different applications as long as we have the dots over there. Okay, we have these fundamentals are available and then defined in the standard. How you can use it, how many different applications that you can create around it is flexible. So Dr. Tarek already discussed this. I'm going to skip through these application classes. But in 6G, we may have more of these, okay? All these application, ultra reliable, low latency, massive machine type, enhanced mobile broadband with different type of matrix and with different technologies supporting to these. So this is what 5G, but again, we may have other bubbles that may be overlapping somewhat in 6G, going to 6G. And these are the applications Dr. Tariq mentioned, pretty much penetrating to every part of our world, including transportation, health, education, grids, water, electricity, industrial applications, factories, many, okay? And many more to come later. This is what we have right now that we are thinking, and I don't want you to limit yourself with this. And these are the metrics, set of metrics. Recently with 5G, red colored is latency became so critical, reliability that Dr. Tariq mentioned, five nines, flexibility, mobility, and cell edge rates. Again, along with the other metrics that we are used to, capacity, spectral efficiency, energy efficiency, complexity, cost, and so on and so forth. One thing that we forgot in 5G is this thing, security, which I'm going to come back to it in a moment. Security is something that we ignored. We didn't do much when we were preparing for 5G, and this is one of the problems that I'm going to talk about in a moment, and it's something that we need to fix in 6G. These are some of the technologies that we have developed to be able to address some of those requirements of the 5G, some of the dreams of the 5G. 5 key technologies, but I don't want to limit, only with 5G, but these are one of the major technologies, but there are some other technologies that are used to develop 5G is, of course, new spectrum, especially those millimeter wave frequencies and mid-band frequencies. We divided the spectrum into, in a nutshell, into two parts: frequency range 1 and frequency range 2. These low frequencies are better for coverage, but the high frequencies are better for throughput, for higher data rates. So eventually they are all important. They need to be used properly in a mixed manner, because we need coverage, but we also need rate, depending on the application. So we need to, our devices, our networks should be able to adjust themselves depending on the application to use the proper frequencies. And antenna systems, massive MIMO, multiple antenna systems, it has been there even with 3G, 4G, but with 5G, it became even more significant, like, that laser beam type of transmission that Dr. Tariq mentioned, and, also having multiple transmissions from multiple base stations to a user rather than one single base station communicating to a user. Multiple base stations with multiple beams can connect to a user is very critical. Speaking of that, multi-connectivity, serving a mobile through multiple networks, through multiple base stations, through multiple technologies has become one of the critical part of 5G, because nowadays we want to be able to serve the users with 5G, but with LTE as well, depending on the user's condition, user's preferences, and network availability, plus Wi-Fi as well. So how to integrate unlicensed spectrum into the 5G framework is very critical as well. Flexible frame design, again, flexibility has always been important, will even be more important in the future, because flexibility will allow us to be able to serve different applications. And in the physical layer, in the MAC layer, 5G became more flexible compared to 4G. In the 4G, for example, we use OFDM, carrier spacing, cyclic prefix, and all these kind of things are rigid, not flexible. But with 5G, we develop a multi-numerology, flexible waveform, flexible OFDM structure. And in 6G, I expect that we are going to do even further flexibilities and better waveforms, or more hybrid waveforms that we're going to be developing. And also with 5G, we are doing intelligence in the edge rather than doing everything at the core, everything at the cloud, all the intelligence at the cloud. For some applications, especially those low latency applications that Dr. Tariq mentioned, we have to move some of those intelligence to the users, closer to the users, so that the control plane doesn't have to go all the way to the edge to do some of those functionalities. So, and there are some other technologies as well, to enable 5G. So going beyond 5G, what are we expecting? Again, as I mentioned, security and privacy is something that we ignored in 5G, and we have to handle this problem. In 6G, this is one of the very critical research areas going to 6G. Flexibility, again, 5G has a lot of flexibilities, but not good enough to enable that dream that we have. Coexistence and interference management is also very important. Also, there is a new concept, even though it is old, but radar sensing is a different concept compared to communication, but we are trying to merge these two things. We don't want to call it radar because radar is mostly focused on the speed, distance, location, this kind of things. We want to learn more about the users, as many parameters as possible, whether the user is sleeping, whether the user's heart rates are beating normally, and anything about the user, anything about the user's environment, not just the user, but user's surrounding environment, anything about the channel, anything that I call it radio environment. We want to be able to learn and as many parameters as much as possible from this radio environment, which we call it sensing. Doing sensing and communication jointly is one of the most critical research areas on these days. Why? Because they help each other. Okay. Eventually, these two different things, if we combine them, we are going to make communication better. We are going to make sensing better as well. And then they will help each other to optimize some of those things. Controlling the channel, up until now, we weren't able to control the channel. Whatever we have it, we try to come up with mechanisms at the transmitter and receiver to protect ourselves, for example, diversity, beamforming, and all these kind of techniques are used to protect ourselves against the channel impairments or fading and multipath and all kind of things that happens in the channel. But nowadays, going towards 6G, we are trying to find mechanisms to control channels, utilizing mechanisms like remote reflecting surfaces and backscatter communication and things like that. So again, there are other things that I mentioned. The terahertz visible light communication, quantum communication is also very critical, in 6G. So, many people think that 6G will have a lot of intelligence, will use a lot of techniques like artificial intelligence and machine learning, and integrating these capabilities with communication and sensing, we're going to have a true cognitive intelligent radio, true cognitive and intelligent networks. So people are thinking that 6G is all about intelligence, all about cognition and adaptation together with those mechanisms. Also, in 6G, we are expecting that up until now, most of the operators, most of the manufacturers are focusing on the monetization of the technology rather than focusing on the society, focusing on the well-being of the human. But with the COVID, we learned that this technology is so critical. We need to design the technology to help the society, to help the humanity. So society and human-centric networks are one of the main things for 6G. Serving society, serving the well-being of the people, including the disasters, because our networks, they don't work well when there is a disaster. We design it in a way that it only works during our regular time. But when disaster happens, everything collapses. So we need to really, make them so robust, make them so flexible, so that, we can depend on this technology wherever we are, whenever, whatever happens. Okay, so there is also going to be with 6G human to machine, human to environment interaction through this Internet of Things type of structures. Okay, so there will be interconnection of the physical, biological, and the digital worlds. So it's going to be a complete cyber infrastructure that we are going to be building with 6G. Again, those applications that Dr. Tariq mentioned, virtual reality, extended reality, augmented reality, are going to be some of the applications, including automated driving, Internet of Bio things, communication everywhere, with everything. Even industrial IoT applications are some of the applications going beyond 5G. Where are we right now in terms of 5G status? We have been working on 5G over the last 10 years. The exploratory research started in early 2000, and pre-standardization and standard activities started by around 2016, still ongoing, of course. So by 2019, we already have the first version of the standard, the basic standard, and then we started the commercialization of these 5G products, and the base stations and the networks. Still, that standards are going. Release 15 is the first version of this standard, and then now release 16 and 17. We are now in the era of release 17. There are many features added in the release 17, and then things got a little bit delayed because of the COVID. We were supposed to have the release 17 finished and then start with the release 18, but because of the COVID, things are a little bit delayed. But the commercialization is ongoing. In the meanwhile, we already started doing research for 6G for the next 10 years technology. But while we are doing all these things, be aware that 2G is still there. So we still didn't have the sunset on 2G, because there are still applications for 2G. We were hoping that by 2023 that we could have that sunset. At least in Turkey, we are trying to expand this duration. 3G, is still being used, but the most dominant technology nowadays is 4G, LTE, LTE Advanced, LTE Advanced Pro, and 5G is picking up. This is where we are. As you can see, everything is staggered. All these technologies are active and used. In 5G, we have two different flavors. One is the evolution of LTE. So LTE is not going anywhere. LTE is extremely strong, like Dr. Tariq also mentioned, because mobile broadband is still one of the most dominant applications right now, and LTE is evolving, even in the release 16, 17. So there is that path of 5G, but then there is a new radio of 5G with these new concepts. Of course, the LTE evolution at some point is not going to be sufficient because of that backward compatibility, because after some point it becomes so complex to evolve a standard. Therefore, we have to have a fresh start, and that fresh start, we call it new radio. And these two things are going. So after release 18, probably we will just stop doing improvements on LTE and then focus on the new radio. But again, LTE is going to be there for a very long period of time. And these are the evolution. This is just that little delay that we had in terms of these releases. So release 17, we are planning to end it by next year. We already started the discussion of release 18. Again, these are the evolution of 5G in two different tracks, LTE and new radio. In terms of spectrum, I already discussed about this. We are using now, in 4G, we were using sub 6 gigahertz frequencies, but with 5G, we are now going to millimeter waves. And these are some of those frequencies. Spectrum migration is going to be slow as well, those LTE frequencies. As 5G becomes more and more popular, we are going to migrate them to 5G, but that's going to be a slow process. We have to be very careful because spectrum is extremely expensive and LTE is still a very dominant thing. So this is basically in terms of market penetration, different standards. This one is the LTE. This is 5G. it is picking up slowly. LTE is also, maintaining its position. 3G is dying down, 2G and is dying down. GSM, this is GSM, but still active. As you can see, there is still, a significant portion of our subscriptions are based on 2G. So this is basically, I got it from latest Ericsson Mobility Report. And these are different statistics, different graphics. And my time is running up, so I need to just talk about some of the issues regarding to 5G. One is the operator rollout. I am also looking at from my operating perspective in Turkey. We are a little bit cautious about deploying 5G. There are several reasons for that. One reason is LTE is very strong, very powerful, and doing what we need to do, what we are expecting, especially from a mobile broadband perspective. And also LTE is supporting a massive machine type of applications as well. Low latency, ultra low latency applications are not there yet, but eventually they will be there. Therefore, we are debating whether we should spend so much, money at this point for 5G or just delay things a little bit. So again, the final decision is not set yet, but we are debating because spectrum is very expensive. Nobody is giving us spectrum for free. And the government is, we are going to have to pay a lot of money for the spectrum, and also the capex expenses is going to be extremely huge. So we are not certain about the revenues. Okay, once we deploy all these things, once we purchase all this spectrum, are we going to get that revenue? That's a question mark at this point. So at least in Turkey, it's going to be a gradual thing. In US, China, 5G is coming very strong, especially in US. China is also very strong. In also South Korea, Japan, trials are ongoing. Europe is like Turkey is a little bit cautious, is lagging behind. But interestingly, even though US is deploying these 5Gs, but they are not able to charge extra for 5G services. It's more like a premium thing for the operators like Verizon, but they are not getting the revenue. Maybe they are stealing the customers, and in order to be in the competition, then everybody has to deploy 5G. Otherwise, some of one operator's customer who's not doing the 5G will go to the other operator because that other operator is providing that premium service. But again, that profitability of 5G is a question mark. But there are very good use cases, like Dr. Tariq mentioned, especially that fixed wireless access, wireless fiber that Dr. Tariq mentioned is critical. Enhanced mobile broadband is critical, and the emerging IoT applications are very critical. Eventually, we are gonna need these things along the line. One major concern of 5G, yes, Dr. Tariq mentioned about that health concerns and things like that. Even though in the YouTube, in social media, you see a lot of bad talks about 5G regarding to health, but really that's not the main thing for 5G. The main thing is the cybersecurity concerns, where nobody is talking about right now. 5G brings a lot of concerns on privacy and security, especially going beyond 5G, and our communication is going to be very vulnerable. Protecting the data using crypto-based techniques are not going to solve our privacy and security concerns, because you are only protecting the data. You need to protect the communication, because if two cars are driving, even if you protect the data, if you don't protect the communication, you can't avoid the collision. So we need to come up with mechanisms to protect the communication. Also, you need to protect your environment, your privacy. Even if you are not an active transmitter, even if you are not an active user of wireless technology, the passive electromagnetic radiation impinging on your body will reflect some of your information, because any time that a radio signal is hitting you and then reflect it back, it's gonna get something out of you and then carry some information about your position, about your location, about your some of your context. And that receiver, a bad guy who can process this information and then get some critical information about you. So that's this kind of technology, Internet of Things, a cyber world where humans are interacting with the environment and then everything is connected with each other. This is a very, very scary world. And this cyber world, if not protected, is going to cause a lot of problem. Therefore, for me, this is the main concern. And the technology wars between US and China is based on this thing here. Protecting the data is very critical. Protecting the user context and privacy is very critical. Another major problem for 5G and beyond is the dominance of major players. Huawei is a number one producer now, and it is a number one market player operating in many countries. I mean, they are not the operators, but they are providing the infrastructure for the operators. In Turkey, 80% of the market is supplied by Huawei. In many countries, Huawei is very, very dominant. And dominance of these companies is scary. Okay? Eventually, I believe that whoever controls the communication infrastructure will also control the world. Whoever controls this infrastructure will control the data. So this is a technology war, okay? And not only that, there is a network, non-terrestrial network concept is coming up. Very big players like Amazon, SpaceX, Facebook are deploying a lot of low orbit satellites. Google planning to deploy balloons. And some big companies are trying to deploy hundreds and thousands of, several thousands, tens of thousands of satellites to develop a network in non-terrestrial world and becoming so major, so dominant. Okay, and even the local authorities will not be able to say much because they are kind of like operating in a region where the local authorities don't have much to say. So this is another thing that comes, beyond 5G. With that, I'm going to stop now. Yeah.
Okay. Okay. Thank you very much, Hussein. Really interesting
sorry,
discussion.
I think more than I'm allocated, but there are so much to talk, Teddy.
Yes.
20 minutes, 30 minutes is not enough. Again, inshallah, one day we're going to have more time to talk about all these things in more detail.
Yeah, inshallah. Thank you very much for both panelists. Very interesting presentation that you have given us. So we have several questions actually, Prof. That's why I need to stop you. Otherwise, we cannot address the question. But maybe for perhaps I will take the first opportunity if Tan Sri Rector has question, maybe, or Prof. Norbik has question. You are welcome to ask first. Once again. Any question?
Thank you very much for a very enlightening discussion. Certainly, I'm very amazed at the kind of technology that it is beyond my comprehension. When you talk about what has been going on. But my fundamental issues is basically looking at the world as it is. When priority is on food and priority is on survival, priority is on security, how much of this technology is actually helping the third world countries? I mean, certainly China, US, they are into this, but country like us, when priority is so different and we are asked to jump into 5Gs, even in the 4Gs, if I can talk on behalf of Malaysians, there are still many of us are not even getting the tip of the 4Gs, So now our attention is shifted to another one, and the 6G is just coming next door. I don't know. As a policy decision, as a person who wants to make decision for the many, what sort of advice would you give?
Dr. Tariq, shall I
Okay.
answer or you want to answer the question?
Yeah.
Maybe you can answer first.
Yeah.
Okay. Please, Professor.
So, Dr. Razak, you have a very good point. I mean, like, yes, it may sound like communication is luxury for many people, especially in the third world countries. Especially, I mean, like, it was luxury to me, 20 years ago. But today, I don't know whether I can live without communication, without internet. I don't even know my wife's telephone number. I mean, I'm so addicted to internet, so addicted to this. So I don't know whether I can live without it. I mean, my kids definitely cannot. I mean, like, because they don't even go to visit our friends if they ask, do they have internet over there? Because they don't go anywhere if they don't even go to holiday vacation. If we go to a hotel, so what was luxury then is a must now for many of us. And you are right that yes, still for some it may still sound like luxury, but like during the COVID, can you imagine an education without connecting? We all of us did this education online in US, in Turkey, and even those places, rural areas, remote places, we found ways to provide them internet. Otherwise, these 2 years were going to be lost. And in the old days, when people used to go to the hospitals to get, treatment. But as Dr. Tariq mentioned, today they don't even need to go to hospital. Immediately we can react. So even for the third world countries, even for those places, eventually these technologies are going to be must if properly designed. I mean, properly designed, what I mean is we have been designing these systems to make money. We need to design them to serve people. Okay, if we design, okay, and also this some of these technologies are changing the way that our kids are living, and I'm not happy what I see with the youth, with the generations. Yes, there are so many benefits, but at the same time there are so many bad things that's happening. Okay, so using the technology properly, designing them properly is a very critical thing, because otherwise we are going to lose the humanity. I mean, like, imagine that your whole electricity grid is controlled by wireless technologies with 5G, and this control is in somebody else's hands. This is very dangerous. The whole water grid is controlled by somebody else. They are injecting anything, because we are designing a water grid where we can inject chlorine, or if it is bad person can inject a disease. So controlling, monitoring a network, a grid is good, but if it is designed and controlled by the good people, otherwise it's going to be a disaster.
Okay.
Thank you.
Okay. Kasri, maybe I can add on, especially looking into currently, the internet, for example, connection is become one of the utility. It's just like a requirement, like a water, like an electricity. And what happened now when the pandemic happened before, we can see that the internet usage increase, but the speed reduced. Where we are talking about they're moving from the office areas or into the uh, where we have this, the housing areas and so on. And all are working from home, for example, here. So the internet's become very important. That's why I think, that's why we are talking about in Malaysia, the 4G is very important at the moment. They want to expand one of the jendela that the program by the Malaysian government is having the first phase to have 96.9% coverage with 35 megabit per second. Meaning that you can see now a lot of complaints, a lot of them in the to a digital divide, for example, in the zone 3, remote area, rural area, they are complaining of the quality of the internet. This is where I think the government have put a lot of money to ensure that at least 96.9% of those populated area, meaning populated area means there are 20 people more per kilometer square available to access those, because it become the requirement from there. And also in terms of moving forward, because we're talking about 4G to extend further, but the moving forward, for example, how 5G can benefit the peoples. We are not talking, of course, we are not talking much about the autonomous car. We are talking about, but we are looking into, for examples, to have fiber to be connected to the premises. Okay, to get fiber layout direct to the home is quite costly. And quite, maybe the 5G can be one of the solution to overcome this problem. And another thing that can benefit the people in the rural area, for example, you have a clinic desa. And if because there are at least the general program where the fiber can go to at least 96% of the coverage, we have a tower over there, and then the tower is fiber connected, and then you can have the clinic desa, for example, the people kampong area where they want to meet the specialist or the doctor don't have to travel to the town. They go to the clinic desa there where have the facility as if the doctor is there, because as if you are in France. There is a remote consultation. So those are the examples where maybe that can benefit to the people. Okay.
Yeah, thank you, Professor Tariq. Tan Sri Rector, do you have any other question? Do you have any further question?
Just one more. I think, as Dr. Hussein was saying, as you increase this question of monopoly and stuff like that. So, at what point do you balance it with ethical values so that you don't get you don't get overwhelmed by this? I mean, when you talk about our kids, which is true, that they are almost addictive to these devices, they are losing their humanity. They are losing their humanness. I mean, for Islam, I think is quite a big challenge that you lose your fitrah at the same time, that you become, dependent on something else. So where do we put this in terms of education so that they don't lose this balance? I know communication is important, but sometimes there are a lot of traffic, but the content is zero. A lot of communication is more of noise rather than content, rather than substance, rather than educating people just out of talks and nothing else. Where do you put these ethical values in when we talk about 5Gs or 6Gs?
Yeah, well, excellent question, Dr. Razak. I mean, excellent question. Unfortunately, even I am hopeless in this. I mean, I have my own kids, my own nephews, many of my loved ones, where I'm, at least in my circle, trying to advise them to use these technologies properly. Internet is beautiful, but there are so many bad things and so much information dirtiness out there that we are exposed to. And we have also very good information there that's valuable. And selecting the right information and benefiting from it without, exposing to all this dirtiness, even though right information is only 1% and the dirty information is 99%. And this requires, especially for the Muslim countries, this is very. We are losing some of our values, some of our ethical values. Our generations are not the same, and there is a discontinuity even with my generation and with the second generation, with the kids. We are not even able to communicate with them because they are being fed with internet rather than with us. We used to get the first education from our elderly ones, from our fathers, grandfathers, and I see a lot of I have a lot of concerns, Dr. Raza, a lot of concerns. I think we need to teach our kids at school in early ages how to use these technologies properly, ethical values, moral values, and all these kind of things. It's just because they're gonna use it. I mean, we can't just block our borders and then say that no, I'm not gonna allow internet in my country. I'm not gonna allow iPhone in my. We are not able to do that. We are actually using in Turkey these phones, this technology more than the European countries, more than the US. And our kids are kind of like and my kids are buying new phones every year. They don't even want to use iPhone 12. They want to get, if the iPhone 13 is there, they want to get that right away. Okay, and just this is crazy. I mean, this is not right. Where do we put the lines? What do we do? I think we need to educate them. We need to educate them. I don't see any other choice.
Okay, thank you, Prof. Hussein. Prof. Tariq, you have any comments on Tan Sri
Yeah,
question?
I think I agree with Hussein. It's important that I think the parents has to monitor because we cannot at moment since with this online and all the study, even the standard one. I mean, the young children they have to use the device, so the parent has to be monitoring them and you have to assist them. Okay, but because with the pandemic situation currently, there is no choice because all have to be study from home, your school are closed, and these are the only means. And that's why the government also giving all the devices to all those people who are not afford. Otherwise, they cannot continue their education and so on because you cannot go to school. The only ways that you can have is by having the device to be connected to the teachers on online. But of course, the parent has to be what you call properly monitor together. I mean, because you imagine the children with very even standard one is also taking into that. There's no choice for them. Okay, before we see that they are always